This is the Unit 6 review for Math 2 Honors. So number 1, we have a proportion in which we need to solve for x. When you have a proportion which is one fraction equal to another fraction, you can quickly cross multiply to solve. So we're going to multiply x times 14 and 8 times 35. And we're going to use this equation to help us solve for x. Eight times 35 is 280. And then 280 divided by 14 is 20. So D is our answer. Number 2. Again, we have a proportion, so we can cross multiply. We're going to multiply the 5 times the x plus 10. So 5 times the whole x plus 10, so I'm going to put the x plus 10 in parentheses, is equal to 3 times the 45. Distribute 5 times x, 5 times 10 is equal to 3 times 45. Which is 135. Subtract 50, and we get 5x is equal to 85. And then divide by 5, and we get 17 for our final answer here. So the answer's choice is B. Number 3, we have two triangles that are similar to each other, and it's asking which side below makes the proportion. So KQ, that's the first two letters from the first triangle, over KL, which is the first two letters of the first triangle. So first two of the second triangle over the first two of the first triangle. And so KM is the first and the last. So I'm going to go first and last from the second triangle, which would be KP. So KP is what we want. Number 4, which proportion is accurate for the diagram shown? So let's check them out one by one. So D over H. So we have the small triangle over the large triangle is C over K, which is small triangle to, now K is not a side of a triangle. K is part of a segment length, but that segment length is not part of a full triangle, so we know A is wrong. Okay, let's look at part B. D over H, so that's small triangle to big triangle. If you don't see the small triangle and big triangle, the small triangle is the triangle that I'm highlighting in yellow. The big triangle is the triangle here that I'm going to outline in blue. Those two triangles are what we're referring to, and they're similar because by corresponding angles we have corresponding angles congruent, and they also share an angle, so angle-angle congruence. So D to H, that's small to large. K to C, K again is not a side length of a triangle, so we're going to throw that out. D to H, that's small to large. And then C, which is small, C plus K is the full side length, so that's small to large. That is true. And D to H, small to large, C to C minus K now. So C is what we want to go with. Number 5. A 6-foot boy has a shadow that is 4 feet. At the same time of the day, a tree has a shadow that's 24 feet. What is the height of the tree? So these two triangles are proportional. They're both right triangles, for one, and we're going to assume the sun is the same part of the day, so the sun's shining. Again, we're going to assume it's at the same place too, so we get the same angle of depreciation and elevation that we can use. So angle, angle, by angle, angle, we have similar triangles. So for the small triangle, I'm going to go base over height. And then the large triangle, I'm going to go base over height. And then we can cross multiply, so 4 times h is 6 times 24, and then divide by 4, so h is 6 times 24 divided by 4. 24 divided by 4 is 6, so this is 6 times 6, which is 36. And we're talking feet here, and so we're going to go with option D. Number 6, triangle ABC is similar to GJL. So we're given some angles here, and angle A is going to be the same as angle G, so those are both 25 degrees, because they give us A is 25. And J is given at 100, and J corresponds with B, so B is also 100. So far we have 125 degrees accounted for inside the triangle, and all three angles add up to 180. 180 minus 125 is 55 degrees for angle C, and 55 degrees for angle L. So, and it says calculate the measure of angle B, that's 100 degrees. Calculate the measure of angle L, that's 55 degrees. Calculate the scale factor of the smaller triangle to the larger triangle. So I'm going to find two sides that correspond, of which I know their lengths. So AB is proportional to GJ. And so the scale factor, what do we multiply 18 by? So I'll call that x for scale factor to get 22. And so I'm going to divide 22 by 18, or we could reduce that, cut them in half, we get 11/9 is our scale factor from smaller to larger. Number 7, ABCEF is similar to WPXZR, and we want to calculate the measure of angle A. So A corresponds to W. W is 85, so A is also 85. and calculate the measure of angle P. P corresponds to angle B. B is 120, so P is also 120. I'm looking at the ordering of the letters, so I notice that P is the second letter here, and so that I know it corresponds to the second letter in the first part. In problems 8 through 10, determine if the figures are similar. If so, complete the statement of similarity, and then B, state the postulate or theorem that justifies the similarity. So on the first one, if we did have similarity, well, first of all, these two triangles, the smaller triangle, again, I'll highlight the smaller triangle, to the larger triangle that it's inside, they share angle L. But if they are proportional, or if they're similar, then their sides will be proportional. So, for example, this side, if we're looking at the smaller triangle, the height is 9, or the left side length is 9, the base is 18, so 9 to 18. The left side of the larger right triangle, or it's not a right triangle, but the larger side of the larger triangle would be 9 plus 6 over 18 plus 12. So let's see a question mark. We don't know if they're equal. If they were similar, we would have proportionality, so we're checking here. The first fraction is 1/2. The second fraction, we get 15 over 30, which is 1/2. So that's, we got proportionality. So these are similar by side angle side similarity. Because we had two sides, the two sides between the angle, or the two sides that make up the angle, are proportional, and then the angle is congruent to itself. So TLZ is going to, we've got to worry about the ordering here. T corresponds to C, L corresponds to itself, and Z corresponds to H. So the second diagram, we have vertical angles, so we know this is 42 degrees, and then we can find our missing angle. So on the right hand side, we have 70 plus 42, accounted for so far, plus, call that X, it's 180. And 70 plus 42 is 112, plus X is 180. Subtract 112, and we get 68 degrees. So if these two triangles were similar, they would have the same angle measurements, and the left triangle has an angle measurement of 88, where the right triangle doesn't, so we're just going to say these are not similar. And then number 10, here we have vertical angles are congruent. We also have RQ is parallel to TU, so by alternate interior angles we have Q congruent to T, and then R is congruent to U, so we have angle-angle similarity. We only need two angles, but we have enough here. And RQS is going to be congruent to UTS. Order matters. Number 11 and 12 are given as similar. We need to find x and y. So 11 and 12. So on 11, 5 is going to correspond in the left triangle with y in the right triangle. And 6 on the left will correspond to 18 on the right. And we can reduce 6 over 18. So we get 5 over y is 1 over 3. And if we cross multiply, we end up with y is 15. And we can do something similar for x. 4 corresponds with x. And again, 6 corresponds with 18, which is 1/3. If you cross multiply the 4x with the 1/3, you get x is 12. You can also just see the scale factor is 3. So if you multiply 6 times 3, you get 18. So multiply 5 times 3 to get 15, and multiply 4 times 3 to get 12. Careful on this next diagram. You're looking at the small triangle versus the large triangle that it is inside. So the small triangle has a side length of y, and that corresponds with the side y plus 9 in the larger triangle. And then the small triangle has a side length of 36, and that corresponds with the side length 36 plus 12 in the larger triangle. Well, 36 over 36 plus 12, that's 48. And I could divide 36 and 48 by 12 and get 3/4. So y over y plus 9 is equal to 3/4. If you cross multiply, you get 4 times y is equal to 3 times y plus 9. Distribute. Subtract 3y, and you end up with y is 18. We can do something similar with x. X is it's the base of the larger triangle. 18 is the base of the smaller triangle. So I went larger to smaller. So I'm going to have 36 plus 12. That's for the larger to smaller, which is 36. Right, the full length here to the smaller length here. So we can reduce a little bit. X over 18 is, well, that's 48 over 36, which is 4 over 3. If we cross multiply, we get 3x is 4 times 18. Divide by 3, and you get x is 4 times 18 over 3. 18 over 3 is 6. So x is 4 times 6, which is 24. In problems 13 through 19, we're going to determine the value of x. So here we have similar triangles because they're parallel, and so by angle, we have similarity. And we could say small triangle, we have x over 5. Well, actually, let's go small to big. It'll work out better for us. So 5 to 15 is, so small to big, is x over x plus 27. Ooh, I messed up here. Should be 5 to 15 plus 5. Small to big. Right, here's the large side is 20. So small triangle to big triangle. So we have 5 to 20 is x to x plus 27. 5 to 20 we can reduce to 1/4. Cross multiply, 4 times x is x plus 27. Subtract x, 3x is 27, and divide by 3 to get x is 9. The next one, again, for the same reason, we have corresponding angles are congruent, so we have angle-angle similarity, and so we can set up a proportion. X to 7, that's big triangle to small triangle, is equal to, so big would be 10 plus 5 to 5. So big to small. 10 itself is not a side length of a triangle. So this is 15 over 5, which is reduces to 3 to 1. So x over 7 is equal to 3 over 1. Cross multiply, x is equal to 21. Same scenario in 15, angle-angle similarity is what we're using here. X to 8 is equal to, careful here, we're not given the side length of the small triangle, but we know the full length is 12, and 3 is the leftover part, so 12 minus 3 is 9, so this has got to be 9. So x to 8 is equal to 9 to 12. And if we divide by 3, we get 3 to 4. So x over 8 is equal to 3 over 4. We can cross multiply. We can also get a common denominator here. If we double the 3/4 to both the 3 and the 4 to 6 over 8, then we see x is 6. But let's just cross multiply here. So 4 times x is 8 times 3. Divide by 4. 24 over 4 is 6. So on 16 and on 17, we're going to use the corollary to the side splitter theorem. It says if we have parallel lines, as in the diagram here, then we can take corresponding segments and say they're proportional. So, for example, we can say 8 over 6 is equal to x minus 4 over 9. So we could reduce our 8 over 6 to, we'll cut them in half and you get 4 over 3. And we can cross multiply, so 3 times x minus 4 is 4 times 9. 3x minus 12 is 36. Subtract 12, you get 3x is equal to, add 12, 48. And then divide by 3 and you get x is equal to 16. could do a similar thing here in 17. 21 over 14 is equal to x plus 8 over x. 21 over 14 we can reduce. Divide them both by 7, you get 3 over 2. Cross multiply, you get 3 times x is equal to 2 times x plus 8. Distribute. Subtract 2x from both sides, and you get x is 16 again. For 18 and 19, notice we have an angle bisector on both of those, and there's the triangle angle bisector theorem that we can use here. And here's how it goes. So we could say that the base over base, so the base of the left triangle is x, the base of the right triangle, the smaller right triangle, is 8, would be equal to the left side 9 over the right side 12. And then we could reduce 9 over 12 divided by 3, you get 3 over 4. Cross multiply, you get 4 times x is 8 times 3. Divide by 4, and you get 6. And last one, number 19, we're going to set up in a similar way. Notice the full bottom length is 20. And so we're going to have 20 minus x be the length of the right side. So because x plus 20 minus x adds up to 20. So when we set up our proportion here, we're going to say x over 20 minus x is equal to 14 over 18. 14 over 18 we can cut in half to 7 over 9. And then kind of ignore the middle fraction and cross multiply. 9 times x is 7 times 20 minus x. Or 9 times x is 7 times 20, which is 140. Minus 7x. Add 7x to both sides, and we get 16x is 140. And then divide by 16. We can at least cut everything in half. We get 70 over 8. Cut it in half again. We get 35 over 4. And that's about all we can do. So x is 35 over 4. Number 20, a student dilates the figure at the right using a center of dilation of 0, 0 and a scale factor of 2. Which is true? So first of all, in a dilation, the new figure is going to be similar to the original. So they're all going to have the same angles, and the side lengths will be proportional. So our options are each angle of the dilated house will be similar but not congruent. That's false, because we know angles are congruent when the figures are similar. B, each line segment in the dilated house will be parallel to its corresponding line segment in the original house. That sounds true. We'll come back to that. C, some of the line segments of the dilated house may have different slopes in their corresponding. So you see how B and C are different. One's parallel, one's different slopes. So you can't go with one, not the other, without rejecting the other. And then D, the distance between the vertices of a line segment on the dilated house will be 4 times the distance between the vertices of the line segment of the original house. Well, that's true. That's false because we're working with a scale factor of 2. So B is our only true one because it's going to be similar and it's going to be proportional, and it's when you do a dilation, it doesn't rotate the figure at all. 21. Triangles A and B are shown to the right. Describe the transformations used to transform A to B. And are the triangles similar? Well, first let's tackle the similar part. I think we can agree that these are right triangles. If we look at the side lengths, we got 2 by 3, and here's 4 by 6, and so I think you could see that they're proportional, and so we're going to go with yes, they are similar, so by side angle side similarity. So that throws out A and B. And then if you look at C and D, what's the difference here? They both have translating 3 to the right and 4 down. And what's the difference here? Translate 3 right and down, 4 down, and then dilate it by a factor of 2 with center 0, 0. I think they say the same exact thing, so we'll take them both, C and D. Oh, no, they don't say it. One says right 3 down 4. The other one says right 3 down 2. Okay. Well, if the center of our dilation is 0, 0, and let's look at a point on this here. So let's say this top point here is at 2, and so the top point of the other, the next one would be half that. We'd want it here. So go from, so we're going to need to go right 1, 2, 3, down 1, 2, 3, 4. So this is what our triangle should look like, and everything should work out good there. So we are throwing out D, going with C. Number 22, for the triangle at the right, graph the figure representing a dilation of the triangle by a scale factor of 1.5 with a center at 0, 0. Should the triangles be similar? Well, yes, because when you do a dilation, you get similar triangles. Should the corresponding sides be parallel? Yes. Dilations are not rotations, and their side lengths are proportional. Should the corresponding sides be congruent? No. Only time that would be true is if we were scaling it by a factor of 1, which wouldn't change a thing. Should the corresponding angles be congruent? Yes, because when you have similar triangles, angles are always congruent. So now we just need to get this drawing here. So this is, let's label these. We got say A, B, C, and we're going to take these and we want a dilation of the triangle by a scale factor of 1.5. So let's get the coordinates of A. Coordinates of A are left 2, down 2. Let's do B as well. B is right 1 up 3, and C is right from 0, 0, you go right 1, 2, 3, 4, down 2. And so we're going to now, by a scale factor of 1.5, so we're going to multiply these numbers by 1.5. So 2 times 1.5 is 3. So this is negative 3, negative 3. 1 times 1.5 is 1.5. 3 times 1.5 is 4.5. 4 times 1.5 is 6. And negative 3. So if I plot these points, so negative 3, negative 3, 1.5, 4.5, and 6, negative 3. So you see, it's a larger triangle, but the sides are definitely parallel. And there we have it. #23. Choose always true, sometimes true, or never true for each statement. Congruent figures are similar. It's always true because by definition of similarity, well, and congruent figures, it's, something similar if it has all angles congruent. That's true in congruent figures. And similar figures have proportional sides, and that's true in congruent figures. Similar figures are congruent figures. That sometimes is true. That's if they're you're looking at the same. If they are congruent, then they're similar. But you can look at similar figures that have different side lengths. You don't need the side lengths to be congruent to each other. You just need the angles to be congruent to each other. So it doesn't always have to be true. C, the length of a 2-unit segment dilated by a scale factor of 5 with center 0, 0 is 7 units. That's false. They're adding here. If you have something that's 2 units long and you dilate it by a scale factor of 5, you're multiplying that length by 5, and so it should be 10. So never true. A dilation takes a line not passing through the center of the dilation to a parallel line. Let's read that again. A dilation takes a line not passing through the center of the dilation to a parallel line. And that's true. Always true. Part E, a dilation takes a line passing through the center of a dilation and translates it up by a scale factor. That's false. If you have a line passing through the center of this dilation, its dilation will also go through that center as well. So that's a never true. There is a similarity transformation between two rectangles. That's not true because you don't have to have proportional rectangles. You can, though. You don't have to, so we'll say sometimes true. There's a similarity transformation between two circles. That's true for all circles because all circles are proportional. Triangle dilations can be proved similar by AA similarity postulate. And that's true. That's what the AA similarity postulate does prove triangles similar, and in dilations you can argue that since the sides of your triangle stay parallel, that the angles are going to stay congruent, and then you can use that AA similarity postulate. And that's the end of our review.